Hello, Mr. Betts here. Let's take a look at a couple examples that use the ratio test. So first of all, I want to point out that the first part of this question doesn't ask anything about convergence or divergence. It's just asking what the limit is. Now, that's the limit we're going to use for the ratio test to determine convergence or divergence, so that's going to be useful to us to answer that question later. So first thing we want to find is this limit as n approaches infinity of a sub n plus 1 divided by a sub n. So I'm going to just rewrite that limit and put in n plus 1 for n. So for the a sub n plus 1, that's going to be n plus 1 minus 2 over n plus 1 factorial. So that's the n plus first term. And then instead of dividing by a sub n, remember we can multiply by the reciprocal of a sub n. So a sub n is just that expression there. But if we're dividing by that, we're going to multiply by n plus 1 factorial over n minus 2. Okay, and remember also that's in absolute values. So now we need to look at what's going to happen with this expression and hopefully do a little bit of canceling. Let's rewrite this n plus 1 plus 1. That's going to be the same thing as n plus 2 factorial. And I'm thinking of that n plus 2 factorial as n plus 2 times n plus 1 times n minus 1, and so on. And that's the same thing as n plus 2 times n plus 1 factorial. And the reason I'm thinking of it that way is that we can cancel it now with that n plus 1 factorial there. So what happens here, we can get rid of that now. The n plus 1 factorials cancel, and we get that. So what's left, I'm going to rewrite now, the limit as n approaches infinity. N plus 1 minus 2 is going to be n minus 1 on top. And on the bottom, we have n plus 2 times n minus 2. Okay, and still looking at the absolute value. However, I want to point out that when n gets really big, n minus 1 is going to be positive, n plus 2 times n minus 2 is going to be positive. The only time those are not going to be positive would be if the n minus 2 could be negative, and it's not. Not when n is big, at least. So the next thing that we want to do is look at relative rates of growth. We have a polynomial divided by a polynomial, but what's important here is that the degree on the bottom is n squared. So we have n squared minus 4 on the bottom. Since the bottom is growing a lot faster than the top because the n squared dominates the n, this is just going to be 0. Okay, so first answer here, answer to question number 1, that limit is 0. So then question number 2, based on that answer, what does the ratio test say about the sum of this series? Well, if we look at the sum of this series, remember the ratio test gives us, there's 3 options. If r is less than 1, one thing's going to happen. If r is greater than 1, another. And r is equal to 0, another. So if r is less than 1, it's going to converge. And that's going to be our answer here. If r had been greater than 1, then it would diverge. So the series would diverge. Sorry, that should be a 1. R equals 1 here. If r is equal to 1, then the ratio test actually doesn't help us. We're going to have to figure out whether the series converges or diverges some other way. So another example, this one's a little bit more complicated of an expression. So it's going to be a little trickier to get set up and do some canceling, but we should still be able to do that. So keep the limit on here. The limit is n approaches infinity. So remember, we're going to do the n plus first term first. So what we get when we plug n plus 1 in for n. Doing that here, that's going to be 3n plus 3. So this is going to be negative 2 to the 3n plus 4. And then in the denominator, we're going to have 5 to the n plus 1, and we're going to have n plus 1 to the third power. So that's that whole expression right there is a sub n plus 1. Then we want to multiply by the reciprocal of a sub n. So we're dividing by a sub n, so we're just going to multiply by the reciprocal, 5 to the n times n to the third over negative 2, 1 plus 3n. and absolute value that whole thing. Okay, so we want to just take this one piece at a time. And what I usually like to look at is the pieces that kind of correspond to each other. This is the way we're going to be able to do some simplifying. So for example, the 5 to the n plus 1 and the 5 to the n, we have in the numerator 5 times 5 times 5 times 5 n times, and in the denominator we have one more of them. So we can cancel all the 5s in the numerator with all but one of the 5s in the denominator. With the negative 2's, we can do something similar, except we have here, we have 3 more of them than we have here. And that's because we had to distribute that n plus 1 right there. So what we're going to end up with is all of the negative 2's in the denominator are going to cancel with all but 3 of the negative 2's in the numerator. Sorry, that should be a 3. I also want to point out with this term that negative 2 to the third power is negative 8, but since we have absolute values here, that's just going to turn into a positive 8. So I'm going to just rewrite this as 8. The last thing that we have here is the n cubed and the n plus 1 cubed. I want to talk about that in just a second, but I want to simplify, rewrite here, because this is getting kind of messy. So we have that 8 and the 5 left over. The 8 and the 5 are going to be multiplied in every term. So as n approaches infinity, the 8 and the 5 are not going to change. So I'm going to take that outside the limit. So we're going to have 8/5 on the outside times the limit as n approaches infinity. As n gets really big, n plus 1 and n are going to be big, positive numbers. So we no longer need the absolute value. And so the last thing is we need to evaluate what happens when n gets really big with this expression. They're both polynomials again. We have 1n cubed on top, and in the denominator, we're going to have an n cubed, a 1n cubed, plus some other stuff of lower degrees. So that limit is going to approach 1, and it's going to give us an overall limit of 8/5. So using that answer, 8/5 is greater than 1. So remember, the ratio test says that if this ratio is approaching something less than 1, the series will converge. If this ratio is approaching something greater than 1, it's going to diverge. So again, the third possibility is that ratio is going to be equal to 1. And in that case, if the ratio is equal to 1, we're going to have to do some analysis in some other way to answer the question of whether the series converges or diverges.